Hey guys, in today's video we're going to be talking about the SAT math questions under the question type of right triangles and trigonometry. And these type of questions usually have an element of right triangles and trigonometry, shockingly. Okay, so just going into the first question, we're going to be tackling Pythagorean theorem and perimeter. So in triangle XYZ, angle Z is a right angle, and the length of YZ is 24 units. If tan of X is equal to 12 over 35, what is the perimeter in units of triangle XYZ? It's a good question. So just like drawing it out, make sure you draw the right angle first, so it's less confusing. Then X, then Y, and then YZ is 24, so 24. Then tan of X is equal to 12 over 35. So tan of X is going to be the opposite side, so 24, over the adjacent side, which we don't know. So we can write it like this. Tan of X is equal to 12 over 35, which is the given value. And then that's going to be, in the given model, 24 over adjacent. So to find out the adjacent, it's just going to be some simple algebra. Take the reciprocal of this equation, you're going to get a over 24 is equal to 35 divided by 12. Multiply both sides by 12, you're going to get a divided by 2 is equal to 35. Multiply both sides by 2, you're going to get a is equal to 70. So now we have that value. In order to find the hypotenuse, in order to calculate the perimeter, we're going to use the Pythagorean theorem. That's going to be, of course, a squared plus b squared is equal to c squared. And we already know a and b, the opposite side and the adjacent side, so we're just going to plug that in. That's going to be 70 squared plus 24 squared is equal to c squared. And taking the square root of this in your calculator, it's going to be 70 squared plus 24 squared is equal to c. That is going to be equal to 168. So B is the correct answer. Alright, so for the next question, we're going to be talking about the area formula. In triangle XYZ, angle Y is at right angle. The measure of angle Z is 33 degrees, and length of YZ is 26 units. If the area in square units of triangle XYZ can be represented by the expression K tangent of 33 degrees, where K is a constant, what is the value of K? Question mark. So the area formula, of course, is going to be 1/2 base times height. And that's apparently going to be equal to K tangent of 33 degrees. And then to model out the given triangle, we're going to first write out the right angle, Y, then X and Z. And then it's given that YZ is equal to 26 units, so we're going to write that down. It's also given that the angle of angle Z is 33 degrees. So we're also going to write that down. And you can write that out as tan of 33 degrees is equal to the opposite side, which we don't know, so we're going to write that down as H. Or actually, we can just write that down as B. Makes more sense for the question. So B over the adjacent angle, which we do know, which is 26. So to find B, you can just multiply both sides by 26, and that's going to yield you B is equal to 26 tangent of 33. So inputting these two values into the original equation, you're going to get 1/2 26 times 26 tangent of 33 is equal to K tangent 33. Dividing both sides by tangent of 33, you're going to get 1/2 26 squared is equal to K which if you put that into your calculator is going to be equal to 338. And that is the correct answer. Alright, so for the next question, we're going to be talking about 30, 60, 90 triangles. Yeah, right triangle ABC is shown. What is the value of tan A? So we're given two angles here, 30 degrees and 90 degrees. 30 plus 90 is equal to 120. 180 minus 120 is equal to 60. Therefore, this angle A, is going to be 60 degrees. So then we know we're dealing with a 30, 60, 90 triangle. The general rule of thumb for 30, 60, 90 is that the hypotenuse is going to be equal to 2, let's say x. The side opposite the 60 degree angle is going to be x times the square root of 3. And then the side opposite the 30 degree angle is going to be just x. So to figure out x, we're just going to divide 54 divided by 2. So that's going to be x is equal to 27. So then to find tan of A, that's going to be tan of A is equal to the opposite side. So x times square root of 3, so it's going to be 27 over square root of 3 over, well, x, so that's going to be 27. And that is equal to the square root of 3. And therefore, C square root of 3 is equal to the correct answer. Well, is the correct answer, anyways. Alright, so for the next question, it's going to be an equilateral triangle question. So the perimeter of an equilateral triangle is 624 centimeters, and the height of this triangle is k times the square root of 3, where k is a constant. What is the value of k? So we're going to write out the equilateral triangle model. And basically what that means is that each side of the triangle is equal to each other. So like, let's say A is equal to A is equal to A. And that's how you can express the equilateral triangle. And of course we're given the height, and the height is like what happens when you stick a line down the middle of a equilateral triangle. And then the value of the length of this height is going to be k times the square root of 3. So to find the perimeter, it's going to be P is equal to 3A, because of course the perimeter is each side added together. So A plus A plus A is equal to 624. So dividing both sides of this equation by 3, that's going to be A is equal to 208. So then the hypotenuse of this right triangle formed by the height is going to be equal to 208. And let's just model out this right triangle in particular. So the hypotenuse of 208, sorry, and then the base of A divided by 2, because it's split down the middle, so that's going to be 104. And then the height is equal to, it's given as k times the square root of 3, but we want to find k. So to do this, we can use the Pythagorean theorem. That's going to be a squared, so 104 squared, plus b squared, so k times the square root of 3 squared is equal to 208 squared. Subtract both sides by 104 squared, you get 3k squared is equal to 208 squared minus 104 squared. Divide both sides by 3, and then take the square root. You're going to get k is equal to square root of 208 to the power of 2 minus 104 to the power of 2 divided by 3, which is within the square root because that comes before the square roots, because it's part of the k, not the 3. Anyways, then shoving that into your calculator is going to be very difficult, as you can see, but I think you can do it. It's going to give you the answer of 104, which that's equal to a divided by 2. So that's kind of a hint that there's definitely an easier way to solve this, but I think the most consistent manner to memorize a solution to this problem is just the second 2. Method. So yeah, k is equal to 104, and that is correct answer. Alright, so then for the next question, we have a very difficult 3, 4, 5 triangle. In the figure above, tan B is equal to 3 divided by 4. If BC is equal to 15 and DA is equal to 4, what is the length of D? So BC is 15, and AD, or DA rather, is equal to 4. What is the length of D? Okay, so we know that tan of B is equal to 3 divided by 4. We don't really know what AC or BD, or BA rather, actually is, but we do know the ratio between them. That's going to be opposite for tan B is going to be 3, and for BA that's going to be adjacent, so 4. And then since we don't know the exact value, we're going to use a scaling factor in this situation, k, and then k. Then to find the value of k, we're going to use the Pythagorean theorem. That's going to be 4k squared plus 3k squared, remember the parentheses, very important, is equal to 15 squared. So just simplifying that, you're going to get 16k squared plus 9k squared is equal to 225. That's going to be equal to 25k squared is equal to 225. Divide both sides by 25, you get k squared is equal to 9, which means that k is equal to 3, which means that A is equal to AC, the length of the side AC is equal to 9, the length of side BA is equal to 12. So then in order to find the length of DE, we're going to have to compare the triangle of, a side rather, from ABC to a side from the triangle BDE. What do I mean by this? Well, let's look at BA and BD, for example. BA over BD is equal to the value of BA, so 12, divided by the value of BD, so it's going to be 12 divided by minus 4, sorry. That's going to be 12 divided by 8, which is equal to 3/2, which means that the perimeter of ABC, the triangle ABC, is equal to 3/2 the perimeter of BDE. So to find any side from BDE, you just take the corresponding side from ABC and then divide it by 3/2, which is in effect multiplying it by 2/3. So to find DE, we're going to look at AC, the corresponding side of DE in the triangle ABC. So multiplying AC by 2/3, you're going to get 9 times 2/3 is equal to 18 divided by 3, which is equal to 6. Therefore, the length of DE is equal to 6, and that is the correct answer. And for this next question, we're going to be tackling an isosceles right triangle. An isosceles right triangle is a really big word, but it's actually quite a simple concept when you get down into the nitty-gritty. Anyways, an isosceles right triangle has a hypotenuse of the length of 58 inches. What is the perimeter in inches of this triangle? So it's a right triangle, right? So the side that's opposite the right angle is going to be the hypotenuse, which has a length of 58 inches. And since it is the hypotenuse, it is opposite the longest angle, therefore it cannot be one of the equivalent legs, therefore this leg and this leg is equal to each other. So to find the perimeter, we're going to have to find the value of a, which we can do using the Pythagorean theorem. So it's going to be a squared plus a squared is equal to 58 squared, which is equal to 2a squared is equal to 58 squared. Divide both sides by 2 and then find the square root. So it's going to get a is equal to the square root of 58 squared divided by 2. And you can rewrite that again like 58 divided by the square root of 2, but you can't just leave it like that. That's an improper fraction. So you're going to multiply both sides by the square root of 2. That's going to yield you 58 times the square root of 2 divided by 2, which is equal to a. So to find the perimeter is just going to be 58 times the square root of 2 divided by 2 twice, so cancel out the 2, plus 58 is equal to the perimeter, which is equal to, I'm basically just rewriting it at this point, but it's equal to 58 times the square root of 2 plus 58, which is the answer choice C, and that is correct answer. Okay, so for the 7th question, we have a diagonal of a rectangle. This is a weirdly very important term for this section of the test. I don't know why, but it appears in a lot of questions. It's not like very difficult, it's actually quite simple, but it's just very much like it's a very reoccurring thing, you know? Anyways, a rectangle is inscribed in a circle such that each vertex of the rectangle lies on the circumference of the circle. This wording in and of itself is really annoying. The diagonal of the rectangle is twice the length of the shortest side of the rectangle. The area of the rectangle is 1089 times the square root of 3 square units. This is the length in units of the diameter of the circle. Okay, so this is the image they're drawing. A circle, and then a rectangle inside the circle, with its corners touching the corner of the circle. And then there's a diagonal, which creates a right triangle inside of the circle, in which the hypotenuse is equal to the diameter, which is important for later because that's what we're trying to find. So it's also given us the fact that the diagonal of the rectangle is twice the length of the shortest side of the rectangle, which means that the hypotenuse of the triangle is equal to 2 times the length of the shortest leg of the triangle. So just modeling it like that. So then to find the scaling factor for this part of the leg, for those of you who are like comfortable with 30, 60, 90 triangles, you probably already know what it is, but for those who aren't, that's okay, I'll explain it to you. We're just going to use the Pythagorean theorem. That's going to be really quickly a squared plus ka squared is equal to 2a squared. That's equal to a squared plus k squared. A squared is equal to 4a squared. And then imagine there's like imaginary 1 in front of this a. So to add this variable to this variable is going to be k squared plus 1 times a squared is equal to 4a squared. Divide both sides by a squared, you're going to get k squared plus 1 is equal to 4, and then that means that k squared is equal to 3, which means that k is equal to the square root of 3. So therefore k of a, the length of this leg, is equal to square root of 3 times a. So then to find what a is equal to, we're just going to use the area. The formula is going to be 1/2 base times height is equal to 1/2 the square root of 3a times a, which is equal to 1089 times the square root of 3.
divided by 2, because the area of the triangle is half the given area of the rectangle.
So then it's going to be the square root of 3 a squared divided by 2 is equal to 1089 times square root of 3.
Divided by 2.
Multiply both sides by 2 divided by the square root of 3 is going to yield you a squared is equal to 1089. And then just take the square root of both sides, you're going to get a is equal to 33. So then, to find the diameter of the circle, we're just going to find the hypotenuse of the triangle, which is equal to 2a. 2a is equal to 33 times 2, which is equal to 66. And that is the diameter of the circle. And that's about it. Alright, so for the final question, we're going to have a corresponding trigonometric problem. So the side lengths of right triangle RST are given. Triangle RST is similar to the UVW, where S corresponds to V and T corresponds to W. What is the value of tangent of W? So to draw RST, it's just going to be a model like this. Right triangle, naturally. And then it's given that TR is the longest side, therefore it has to be the hypotenuse. So TR goes here, and it has a length of 584, and thus S has to be the right angle. Then just like put the given values. RS is equal to 440 and ST is equal to 384. So then to find the tangent of W, we're just going to draw the corresponding triangle for UVW relative to RST. So R is corresponding to U, S is corresponding to V, and T corresponds to W. So to find tangent of W, we're just going to take the corresponding sides of RST. So tangent of W is equal to opposite, which is UV, which corresponds to RS, so it's going to be 440, over adjacent, which is equal to WV, which corresponds to TS, so that's going to be 384. And that is equal to 55 divided by 48, which means that D is the correct answer. And that's about it for this topic. Thank you for watching.